What's up, guys, and welcome back to another math puzzle. In this one, we are given the following figure, which is comprised of 4 right triangles, and they are all equal. And the question is, if we know that the hypotenuse is 5 and this value here is 1, the question is, what is the area of each of these individual triangles? And once again, they're all equal. Go ahead and hit that pause button and see if you can figure it out. When you're ready, hit play, and I'll give you the explanation. All right, so let's take a look and let's break this down in the following way. So first of all, I know that this value right here is 1, and that's great, which means that this remaining value, right, this entire length, take away 1, is this other side. So that's the relationship between the long leg and the short leg. Is there, they have a difference of 1, right? Short leg, long leg. So maybe now I can start to represent this short leg as x, right? Just like I can over here. This same value up here is x, and that's our short leg. And then what about this long leg? What would the long leg be? The long leg, since I know that this additional bit right here is 1, just like that is right there, this would be x plus 1. Now I'm in a really good spot because I've got a representation of the short leg, which is this guy, and the long leg, which is this guy. So the short leg is going to be x, the long leg is going to be x plus 1. Now we're in that zone of right triangles, and whenever we're in a right triangle, we'll try to find side length. A really good bet is Pythagorean's theorem. So that's leg squared plus leg squared equals hypotenuse squared. A squared plus b squared equals c squared. So here we go. I got x squared plus, that is x plus 1 squared equals 5 squared, which of course is 25. Okay. Now we've got a good situation, a solvable situation, and let's keep going. So this foiled out, right? When this binomial is squared, we don't just say x squared plus 1 squared. Nuh-uh. It's going to be x plus 1 times x plus 1, which gives us x squared. Here, I'll kind of show you what I'm talking about. When we do x plus 1 times x plus 1, it becomes x squared plus 1x, which gives me 2x. And then the last one, so again, we're foiling, plus 1 equals 25. Okay, now we've got a solvable quadratic. X squared plus x squared equals 2x squared plus 2x. And then simultaneously, we're going to get everything equal to 0. So I'm going to subtract 25 from both sides. 1 minus 25 is 24 equals 0. Then I'm going to divide everything by 2, and I get x squared plus x minus 12 equals 0. And if you guys remember factoring, now we can just factor this quadratic, right? Boom, boom, boom. And it would be what multiplies to negative 12 and adds to positive 1. That would be positive 4 and negative 3, again, equals 0. And once we get it to this point where it's factored into these two binomials, my solutions are whatever makes this binomial go to 0. Well, what plus 4 equals 0? Negative 4. And what minus 3 equals 0? Positive 3. These are my two solutions, but we're talking about length, so the negative is kind of out. My only valid solution is 3. So x equals 3, which means that the short leg here is 3, the long leg here is 4. Now we've got a great situation. How do I get the area of a triangle? So now I do base times height, and again, base and height are arbitrary, but it's whatever makes that nice right angle. So we see it's a right triangle, so the base times the height, 3 times 4, but don't forget, for area of triangle, it's 1/2 base times height. 3 times 4 gives me 12, 1/2 of 12 gives me an area of 6. So each of these triangles has an area of 6. I hope you enjoyed this math puzzle, and if you did, please click that like button. And if you want to see more math puzzles on the regular, make sure to click subscribe. Thank you so much, and I will see you in the next video. Take it easy.